Welcome back to our Scala lessons, and today we will take actually a break from Scala and we will start looking at SQL and relational databases, the most widely used way of storing structured data around the world, right? We'll learn how this language has evolved. Actually, one of the rare languages which is almost 50 years old, but is still relevant, right? If you learn something SQL today, it will still be relevant probably in 50 years, actually. Quite widespread. Of course, later on in the course, we'll go through a way of connecting our SQL queries to using Scala. We'll be using Scala, but for now we'll start with the very basics before we can proceed. So, we'll start with a simple website called SQL Bolt, right? It's not mine, this is a nice tutorial, and then we'll move on to working with more bigger data sets. So, again, so what is SQL? It is a structured language. Well, again, structured query language to be exact, right? It is so-called domain-specific, meaning it's for accessing data. It's not a language like Scala, which is general purpose, right? But it is basically for manipulating, for creating, reading, updating, or deleting data from a relational database. So we'll also get to what a relational database really is. But in its nutshell, a relational database is a collection of tables holding data in rows with some columns as categories, and we have some way of relations. We have some keys which have a relation between these tables, and using these relations we can retrieve data across multiple tables. That's a big picture view. But again, we'll start with a single table. So relational database represents a collection of related tables, right? But it's basically like you can think of it as a CSV table or Excel spreadsheet, just a single. But for now, just let's use a single table. So this would be a CSDD for your machines. For cars, you have a make, wheels, doors, category, something like we use in Excel or CSV, right? So, but of course you have multiple tables, right? You have one for people, right, for drivers, one for types of driving license, and so another. So SQL is all about, well, as far as queries go, as answering some specific questions of extracting data out, right? But of course also there should be a way of inserting, of updating, of creating records as well. So SQL Bolt, again, it contains some nice lessons. You can see there's about 19. I'd recommend that you go through up to here, probably up to 6, right? And you can also read out those lessons as you want. Again, this is not part of full course, just a slight appetizer. Okay, so let's get started. So we'll write the first lesson. I'll go through quickly. You'll have to do these lessons yourself, right? So, queries, right? You have a table, and the syntax for queries is as follows. You have a select, which is a keyword, right? You have no choice on that. And you say what columns you want from your table, right? And you say from which table, right? Notice a few things here. It is a common convention to use capital letters for these keywords, those ones from SQL language, and use lowercase for the column names. We'll see later that actually SQL is pretty rare, that it's not case sensitive, meaning you could write a mixture of letters and it will still work. However, again, convention is a very powerful thing. We want to keep doing things like everybody else does, right? So we're not going to jump from the boat, right? So we're going to keep using this convention again. So it's standard. So most popular command would be probably the one you should learn. It's like hello world is select all from my table, right? So star stands for everything, right? It's a simple way of saying, okay, what do I have? It's like print line almost, like, yeah, like we are getting some data. So this data set for exploration is you need to find, you have a table with ID, right? Title, director, year, and length in minutes, right? So let's start with the hello world, and I will run it here. I'll do Control Enter, right? And I think, let's see, is it actually, let's see, how do I run it, right? Let me see reset. Oh yeah, Okay, it should be running. Oh, actually, why doesn't it run here? Maybe it is somehow, we need to find, right. So, okay, so this is, of course, this is numbers task 5. So how does it work? Let me show you how you can comment, right? So comments in SQL, you use 2 dashes, right? I used the command / to comment, right? You could do it by hand. So let's solve the first exercise, and you can finish the second, third, and fourth by yourself. So what do? Select title from movies on semicolon. And yes, it worked. So I finished first one. There's check mark. So your task will be to do 2, 3, 4 yourself, right? Just do them ahead here. Do them here, right? So select something, do them here. Okay. So that will be your first task today. Afterwards, right, once you finish, right, you can stop the video, you can continue the video and proceed to the next part. Well, I would, again, maybe I'll show it to you. So you paused it. I'll do it quickly because I want to show the other ones too. So select director, right, from movies, and I have the director, right? Easy, right? And now let's do select, how do I do title, right? And director from movies. Again, I highly recommend you do this yourself, right? Pause it and do the video, do it yourself till once I show, so you don't miss out on some interactive learning, right? And of course this part here, right? Title year, of course. Again, can I do this? Yeah, I do Shift Alt /, so I'll do title and year. Okay, there we go. Yeah, it's easy. And of course this part here, Control X, Control /. I will do Control V, select all from movies. All right, there we are. So that's the first part. So that's first lesson done. Let's continue. So column names, you can do comma separated. Again, notice they use capital letters, but we typically use smaller letters, even for when the actual name was in capitals. Okay, so typically, so this will give you everything. However, we want to usually, or queries, we will want to limit them in some way. Maybe you have millions or maybe even billions rows of data, huge, big data. Well, your good database system will actually limit you, but still, you want to limit yourself as well, right? So you want to actually have some way of limiting. So an easy way would be use where, right? You have a limit, like a filter. Think of like we use them in a Scala, we use the filtering, right? So this is actually sort of similar. We say select columns, and we get them from this table, right? And we use a condition, and we can of course chain these conditions using multiple and or statements. Okay, well, so let's see what we have. So what kind of operators do we have? Well, the first one, which is very rare because this is a very specific programming language, it's domain specific. It's used a single, right? Almost, very few languages have single comparison operator, right? Because we don't use them to assignment in SQL. So they could save it, right? So it's a single one. That's a really rare. Otherwise, these are all you pretty much know. Not equal, less or more. Also, since SQL was developed for humanly, meaning it is not meant even for programmers. It's meant for data analysts, analysis for research, right? Even for just a business man or woman, right? So for researching something, you don't have to be a programmer. So they used also, English. They also added English syntax as well. Between, not between. I mean, you can use either way or both, right? Also, you have in. Something exists in a list or something does not exist in a list. So list is something like a tuple or an array in Scala, of course. Right, okay. So this limits us. So let's see, how do we do it? We have our movies. So how would I find a movie? Again, stop it for a moment, this video, and see if you can do it yourself. Right, so let's find. So I'm going to give you a few minutes, probably like 5-10 minutes, depending how much time you want to take, right? How much experience you have already with SQL, but find the movie with row ID of 6. So select, right? All, I'll keep it all, right? I'll keep all, but I'll add a constraint, right? Where ID is equal 5. No, that's not correct, right? I add 6, right? And I am good, right? I'm doing good. So I'll do this. So I will be lazy. I'll do Shift Alt arrow, right? And not ID 6, but I'll do movies, right? I could use this two syntax, right? Between or this. I usually use, of course, I use less or more, but you can use this between as well. I'll show you both actually. Let's see. So between where year between 2000 and 2001. Is that correct? Yes, that is correct actually, right? So what's an alternative? So well, let's do one more, right? Not, right? Not between, right? Not released. That's easy, right? That is easy, right? So the question is now, so how would I have done this same thing? How would I have done this using, if I didn't want to do it between using my regular programming language? So I'll do this movies year, either we'll do this year less than 2000 or, right, that's only 2 movies, 3 movies, or year over 2000. So same, and so this is same as using not between, right? So again, depends how you build up your queries, right? Year less, right? Same answer, right? Right. So again, notice no parentheses, no nothing, just you use queries. So the order of your keywords is important. Select always goes first, and then you might have some extra keywords like where, right, from, select from, and then you usually have where, and you will see some other ones as well, right? Again, a semicolon ends the query, right? You have 1, 2, 3, 4 queries here, right? You have 4 queries here, right? Sometimes you skip, right? But no, you should know everything semicolon, it's important for ending multiple, for ending queries. So how about this first one? So first 5 movies. So probably ID, I assume is this. So select, let's try this with a, what I mean, title, year, right? Right, I'll do this from movies, right? Okay, we have title year, but we want the first one. So probably ID. So let's do ID, right? From movies, and I'll do where ID less or equal to 5. Is that correct? Yes, that is correct. So the first 5 movies, right? And let's do ID here. It's already solved, but I'll add ID here. So first 5 movies. Right, again, so first movies here are determined by these IDs. So we'll deal with IDs quite a bit here again. So normal table will have a unique ID identifying each row of data. It's usually called a primary key, right? An ID which identifies. So there's no because you might have other data. Maybe you have a duplicate entries, right? But ID will be unique, right? So that is also important. Okay, so we learn our first constraints, and let's see, we can do some more. So a few more, right? We can do non-inequality. You can use this alternative syntax. Again, this is matching, strict matching, and you can also do a wildcard matching, like or not like, right? And it's kind of interesting. SQL is not really super well suited for text searches, for wildcard searches, for regular expression searches, right? It uses some basic wildcard support, right? If you need stronger searching, well, we'll need to use it in Scala, or maybe we need to transfer some data, or maybe use something like a service like Elasticsearch or some other specific text-oriented database system. Of course, I'm talking about like vanilla SQL. Of course, the different dialects of SQL might have some extra extensions, right? So, but originally there's not that much for searching, right? So, also existence of strings. So, these are your commands, and let's see how it goes. So, again, syntax, where, and so we want to see all the Toy Story movies, right? We want to find all the Toy Story movies. So, basically, we'll do this where, title, well, how will we do this? Like, and I could do this. Well, I'll solve it immediately, right? Like this. Again, I'll give you time to finish this, right? Again, take your time, stop the video for a little bit maybe, right? But you always see the hint, right? You can do this. This would solve it actually, right? But of course, it'd be better in case there's a movie toy monsters or toy food or something like that, you want to probably do this toy story, right? And again, add wildcard. That's probably better. Again, notice this wildcard means even if you have a this has no string, this is exact match, this is 0 or more matches, like so 0 or more characters. Of course, I could have done also this oi story, right, or even y story, right, or it's not like this, but this also would work. But of course, in your making your queries, in crafting your queries, you want to be as precise as possible. Okay, so that's first one. Let's see. So last step, of course, will be exactly the same, right? And we'll do something where director equals, we could do John, well, we could do like, but I'll do it exactly. John Lasseter, right? And that's correct. That's all his movies up to 2011, right? And so, again, a great director as far as animation goes, right? So not directed, well, that's easy, right? We know how to do this. We'll do, again, remind that I do this yourself. So what do? I'll do a single inequality. Oh, that's not. So now let's find all the Wall-E movies. We notice there's a time machine and Brandon Chapman makes a movie in 2042. Okay. All right. So let's see what happens there. Right. So we'll try that one. So where movie again. Title is like. It's very similar to the first. So like. You notice I'm using quotes and I'm using Wall. I can do probably like this, or I could use underscore. Let's try this one. Will this work? And or what was the syntax? I forget now. Oh, like this. Val-E and Val-G. Let's see. Where title like. Oh, sorry, yeah, because not equal but like. Okay, yeah. So this works. So like. I could have used also. This is single character, right? This is single, right? So notice is for single characters, right? So single matching, a little bit more precise. Here it wouldn't work because Toy Story has no, Toy Story 1 doesn't have a number, right? So you can't really use this approach. But this is very precise. So again, be as precise as you want. I mean, as possible. Okay. So let's see how else can we do. What else can we do? So a few more keywords. Distinct, unique, right? So we want to get unique. For example, we can use it to have the unique values, right? So, for example, you have movies table, you know, you might have multiple movies from the same year, right? So, we have a way of filtering duplicates, right? Like kind of like we're using sets. Again, SQL and relational database have their background in set theory. So the set data structure we used in our Scala actually also has a similar, well, has some similarities. Okay, so we're going to use distinct, right? And also there's also, later on we'll see, there's also something very powerful which is called group by. Very powerful analysis technique. Okay, so distinct will give you direct, and also, well, sorting, right? Order by. So if you want to sort something, you say but column is going to be used for sorting. Also, you can use sort by multiple columns by specifying multiple columns, and also what type. By default, I believe it's ascending, but you can specify ascending, descending, right? So that's the syntax. Conditions, right? Again, the order of these operations is important. Otherwise, the query will not work, right? So again, these are optional, of course, right? But if you use them, you need to have a specific order, right? So alpha numerically, again, sometimes some database, yes, there is a little, you could say, nuance. Sometimes how you search, right? Like say Latvian or like say Russian or Spanish or some other language have some special symbols. Like how do you sort those, right? There's specific rules in some databases. But in general, you sort lexicographically, alphanumerically, right? So, well, you know, so 0 is less than 2, A is before B, right? A is less than B, roughly like that. Okay, so on two more very important clauses, meaning limits, limit and offset, right? So what's interesting is this is how really for many commerce pages work actually. Things like Amazon or shopping sites, right? You have a database of products, right? Or maybe forum posts, whatever, and if somebody requests like a requests some query, like they do search, right? You return them a first page and you show multiple pages of products. Probably may have 100, maybe 100 mobile phones. And if you go, you do something called pagination. You go through these pages of products, and each time you change the offset. You have a limit of say 20 products per page. Like if you see some query somewhere, right, and you see how many products per page you want to see. So that will be your limit, and offset will be where do you want to start, right? So this is the last one. So this is technically these are the last things you do, right? The order of execution is kind of important, right? So now we can build up on this knowledge. Again, give yourself time, stop the video perhaps if you have time, right? And if you don't want to spoil the solution, I will solve it for you, right? So how will I get all the directors without duplicates? So let's do director again. I'll do, right? But we have some duplicates, right? So what do? I add distinct, and we are good, right? I have my all on alphabetically. Well, I forgot something, didn't I? So I'll do order by same director, right? Alphabetically, I could have done descendingly, right? The other way, right? Ascending, but it's by default. Ascending is by default. Okay, great. So last 4 released, order from most recent to the least recent. So let's do that. So select movies. So first of all, let's select all from movies, right? Right, but we want to order by year, right? On descending, right? On limit 4, right? No more, no less. That looks pretty good, right? So first 5 movies, again, it looks like, again, alphabetically, right? So I'll copy Shift Alt arrow, right? And I'll do this order by year. And let's see. So or ascending, or just I could skip this ascending, right? And I want 5, right? First 5. Okay, list first. Sorted. Oh, sorry. Order by year, but we want sorted alphabetically. First alphabetically, so order by title, right? That's it. Yeah. So first 5 here is defined as being first movie alphabetically. So how would I add next 5? So this is where pagination comes in, right? All I have to do is add offset. All I have to do is add an offset here, offset 5, right? And we will be in a good shape, right? Offset, how much? 2? No, 5. Again, so we skip 5 movies ahead, right? Again, here it's alphabetical order, so you can think of it like up to here without these, right? If I put if I did this like, right, you can see it's incomplete query, right? If I commented this out, right, it'll be all the movies. I'm here, right? And I'll semicolon, right? Come on. It should work actually, right? It actually doesn't work. Order by title, right? So maybe the engine is not working. Okay, Control Z. Now everything's here. Okay, yeah. So too many semicolons, right? Okay. Now everything works correctly. Okay, yeah. So yes, so you can think of it as without these 2 commands, you would see all of the, right? If I move this offset, say, move it to say 10, right? Be different. You see the last movies, and again, we don't have 15 movies, right? Offset 9, right? We would see the last 5 movies, right? Okay, alphabetically speaking. But the answer was 5. All right, I think we're almost done with our introduction. Hope you guys are having fun. I think this is SQL is really very powerful. I mean, even if you don't become a programmer, it's still very useful, even in a business world and manager, again, if you're in other roles, right? So quite useful. Right. So this is a review. Again, this is a review for searching. This is do this. It's a little bit tricky, right? This is a little bit tricky task. This selection queries review. I can show you. There's one. Sometimes for one of the tasks, I believe it's this one here, right? You need to actually enter this, enter the answer directly. Copy it basically. Chicago. Basically, where's Chicago? Where's my Chicago? Here, right? And use it, right? So latitude is north-south, right? And longitude is west to east, right? So sometimes tricky, right? So for Canada, I'm sure you can do this, right? Okay, but maybe, well, Okay, maybe I'll go through this. Okay, so give yourself a little bit of time. Again, this might be longer, maybe 10 minutes. And let's see if I can show you this, right? So it is where country, right, equals Canada. We can do this, right? Easy. No problem, right? Now order all cities in United States. So first of all, we're going to get United States, right? That's good. But latitude from what's north? So north would probably be smaller if I remember my geography correct, right? It'd be smaller. So we'll do this. So where order by what? Latitude, right? And actually that's correct already, but I think descending, no, north to south by the latitude, is that not correct? Descending, is it really? Yes, apparently it is descending, right? So north, right, the higher you go, 90 would be North Pole, I believe, right? So yes, Latvia, Riga is 56, right? So yeah, so Chicago is north, so we need to do descending. Okay, and this is the tricky part here. You could do, well, I'll show you the cheap way of doing it like the way they want, and I can show you also the full way of doing this exercise. Okay, so where country, so west, so basically you do this order by, well, longitude, right? But we don't want to where longitude, right? We want Chicago longitude, right? This is what here, so where longitude, right? Longitude equals less than, and I'll just copy this basically, right? And I believe it has to be less, right? And this is, or more, west of Chicago, ascending, I believe. Yeah, okay, so that's solution. But it's not very satisfying solution to me personally, because I had to go into first, so how would I find this? And this is a little bit more advanced already. They don't teach you in this course. I mean, maybe later on somewhere, but what you could do is, how will you get this data? Well, basically, like this, right? Select longitude from North American cities, where city equals Chicago, right? Okay, that's good. So what we can do is we can combine these, right? So you can do subqueries, right? So let's see. So this is okay, but instead of doing this number, what I can do is I can replace this, right, with a query, right? And I will do a query. I can have this query here, like this Chicago query. So you can build this up actually, quite powerful. So I'll do the select inside, right? And it should work. I hope it works. Yeah, it works. And say, for example, Los Angeles. Will it work? Say Los Angeles. Yeah. Let's see. Select. Maybe it doesn't work here. Does it work here? Let's check. Where? Where longitude? Let's see. Select longitude. It should work. Maybe it doesn't work here today. I wonder. Maybe it's a little bit messed up. Let's see here. But basically, this is a subquery, basically, right? It's a subquery. So you could do, for example, I don't know, New York. Yeah. So this would work, right? Yeah. Now it starts working, right? So Chicago. Yeah. Okay. So it works perfectly. Okay. Yeah. So that's just this engine on a web page is not very well working. Again, usually you use something more stronger, of course. Right. So yeah, this would be actually a subquery, right? So we have a subquery, and of course you can keep going like this, right? So you can build very, very powerful queries. But I should mention this, that each subquery, of course, costs time, right? So if you have a very large database and you have a couple multiple queries, your query can take maybe longer, right? We'll need to talk about things like indexing, how to make speed up queries, and maybe creating views. So things can get quite complicated for something, again, for something more complex. But I hope it gives you some idea how you can, well, do some quite nice, get some information quite easily, right? Okay, so largest population in Chicago, that's easy, right? So select all from North American cities, where two largest, right? So where country equals Mexico, right? Mexico, but that's not enough. That's not enough. We have three of them, right? And well, of course, we want to do this order by population, right? And well, limit to, yeah. That's not it. Why? Because we want descending. Because this is what happened to Mexico City? Well, I wonder what happened. Why is it? Well, descending, right? So they are. Oh, Mexico City. Yeah, 8 million. Okay, yeah. So this is the largest one, right? So good, right? So how about the United States? Well, United States. This will be the largest too. New York and Los Angeles. Right, however, we want the third and fourth. So what we do? We simply add offset. Offset 2. And we gain the third and fourth. Okay, so that will be already the first 5 lessons. Again, I really recommend you do this, like I said, yourself, or just go through them yourself. And the next one will be already on joins. That's something we'll leave for tomorrow. Maybe we'll do it separately, right? However, also because I don't really like the way they've done the joins here, the tables they use, right? They don't really have a good, I don't like the naming. We'll start using a more serious database. This is just some sample. But the idea again, so idea is this, that these tables are linked by ID. So for example, you have a box office records, like how much sales you have. You don't actually have the full information about director year. You only have a movie ID. So this 5, this means this Finding Nemo, right? So this 14 depends to 14 here, right? This Monsters University, right? And so on and so on and so on. So out of this table, if you really need to, you can find who directed this movie, or a title, or the length in minutes. But again, so the idea is this: do not repeat yourself. Keep each piece of information in a separate, well, table, a separate, you can say container, but table, really, right? So there's a whole science, something called normalization, of creating this normal forms for these databases. Again, that goes deeper into your database career if you want to go start creating databases, right? But again, for reading, you don't need to know that much about normalization yet. Okay, so again, there's more lessons here. You can try some more. There's some other ones, inserting, updating. But now we'll move on to a slightly different site on what we'll be using. So again, why learn SQL? If you look at the database engines, this is for all corporate friends and everybody, open source or closed source, pretty much anywhere, right? It gives you a nice survey, right? There's like 400 different IT systems, right? So not surprisingly, well, SQL dominates, right? Oracle, right, which is a paid, of course, relational database system by this huge company, right? It's in the first place. Interesting, ironically or not ironically, second place is MySQL. Very popular, at least used to be very popular, well, still popular in different web development services. However, who owns MySQL? Oracle owns MySQL. They bought it, and funnily enough, when they bought it, it was open source. So MariaDB, people who didn't like the corporate policies of Oracle, they created their own MariaDB, and it's also there, up there, right? Maybe it's still, MySQL has a lot more history behind it. But also, Microsoft SQL Server, again, hugely popular, PostgreSQL, and only then at 5 you have NoSQL databases. Those we will learn more in our second course, right? Hopefully in the summer when we have our second course, right? Redis also, the Elasticsearch is for searching, I mentioned, this is more like a search engine. But again, Access, well, again, it's not pure SQL, but SQLite, right, is what we're going to be using. So SQLite, don't let the name SQLite, don't scare it, think you it's not really that light as you think. It's extremely powerful. It has some limitations, right? Meaning it's for one user, right? But one user could be a program. It could be, it's extremely powerful. It can store up to, I think now up to 120 terabytes. When I heard maybe now 280 terabytes in a single file. But it has a very simple model underneath. I mean, for using, it's a great way of learning, and also you can use quite a bit in production for certain uses, right? If you don't need multi-user support, you don't need multi-level access and some other things, right? It has quite powerful capabilities. And again, the syntax you learn in SQLite will work also on these big commercial engines as well as SQL Server or Oracle. So to use it, right, to write some more queries, we need to have a real stronger database. So where do we get it? Well, you are in luck. I already created it for you. It's actually from SQL tutorial. I added to our course materials. Remember Scala Playground, source D, source DB. So do pull and you will have it. Chinook and SQL sample database color. It's very important also that you get this this color page, right? So where did it come from? It comes from a place called SQLite tutorial, but they don't come. This Chinook is actually, it's not from them. It comes from again, the original source is not clear, but it is open, just a small data set of, well, a fictional purchases from a iTunes store in early 2000s. Again, but why it's good, it illustrates all the basics of relationships, right? We'll go more in detail later on in tonight, perhaps, or later on in this course. But you can see these little keys, right? So these keys, you see these IDs. So each table have these nice so-called primary keys, which uniquely identify the row. So this is so-called schema, right? Schema, which tells you what the data is like in this database. It's very important, right? If you don't have it, well, there are ways of generating this. Sometimes you have database, you don't have a schema. Well, you can generate it. So what we'll be using? We'll be using software. Again, I mean, I could be writing we could start writing your queries in Scala, but that is not quite what we want to do yet. We'll practice more with specific tools. So this tool is called the Beaver. Again, it's going to be available in your course materials where to download the Beaver IO, right? You just click here. It's a universal data tool for developers, from pretty much anybody who needs to work with databases, right? You could use an alternatives, but this is a good, excellent tool. Download, install, it will work on your machine, any OS, Linux, Mac, or Windows, and I'll show you what it looks like. So I'll run it. I'll show you basics on how to work with it. So I have a community version. There's also a paid version, which is mostly for corporate use, right? So, we have a nice query already, right? But let's see, there's new version. I'm using an older one from last year. There's not too many changes, but I will close all the databases, right? I'll close all these queries, right? So I'll show you some nice things. So I'll close everything. I'll show you how to connect directly to our database. So I have lots of connections, right? But I will connect here. So sorry. So you do a new connection, new database connection. Look at this connection, this plug, right? This little plug, upper left side, and do this. And well, you can actually click here, right? Actually, it offers you here actually. So you can do also this new. I'll do the full one. New. Oh yeah, let's do new, right? New database. Yeah, database connection, right? So I could have done this here, but I'm going to do it here, right? And I'll call it Chinook Scala March 22. Okay. I don't have sorry, I don't have wizards. I don't just general, right? Well, connection, database connection, right? Yeah. Next. Yeah. Okay. So this is the one. So select connect to database, right? So you see a huge number of database connectors offered by this, right? But I'm going to use the first one, SQLite, right? Here, right? Again, I'll do it again. I'll do it again. So if I do it here, SQLite, it's already there. Actually, so that's even shorter, right? If I do it through here, that's easier. But I'll do the full way. So new, skip just database connection, right? Next, no wizards, no helpers, just by hand, right? Okay, there we go. SQL, right? And now I need to find the path. Just need to find it again. So it's that's why I'm using SQLite. I don't need the password. I don't need if you have access to this machine, you can access the database in a more fuller database. You have a password, perhaps you have connection. Here all you need the direction to the file. So where it is, you need to find it, right? Let's go to our file. In my directory, I have users, right? My val, my name, my username, right? And I have idea projects, right? And I have a Scala project here somewhere, right? So, and I have source, resources, DB, right? Here you go. Nice little mini widgets, right? So I can open, okay, and finish. Let's see what happens. And will it work? Do I have it here somewhere? Is this the one I see? Ah, there you go. I didn't rename it. Okay, that's not the one. Did I do it from, where is it? Where did I go? Where did I go? Let's see. Did I actually skip it? Or is this the one? Let's check. But I have a lot of these Chinooks. Oh, there you go. Or did I make it incorrect one? Well, okay. I guess I don't see. Oh, here it is. Yeah, 7. 7 is correct. So 7 is correct. Okay. So of course I have variation of this database everywhere. Right. So tables. Right. Let's check our tables. Right. You see all tables, and what we want is something called ER diagram. Okay, so that's exactly the same thing I showed you in a JPEG in a picture, right? So this one here, right? It tells you how the tables are related. So let's see again. So you see, I can move them around a little bit. I think I can move them around. Yeah, I can move them around, right? So you see these relations, right? So they say, okay, so one-to-many relations, meaning, for example, so each album, right, can have multiple tracks, right? So each track can have, well, has some certain genre, right? For example, well, a invoice, well, has a customer, right? For example, right? And we'll see more about this, how there's invoice items, maybe why there's invoice and invoice items, there's some other things, right? Why there's a playlist track and playlists, right? How it's done. But for now, let's concentrate on tracks, for example. Let's look at it. Let's make a query. So SQL editor, I believe we can do this like, yeah, open SQL script or new SQL script, control and bracket, right? So I'll make a new script like this, and I have big font. So let's do select, and notice this from, right? Select all, from, and I will do tracks, right? Tracks, and notice if I do this, right? Right, it automatically creates a shortcut. By the way, will be important later when we do joins. And let's do select limit 25, and let's do Control Enter, and there we go. For those who are about to rock you, right? We have a nice little database. I wonder who the author could be to this composer. So notice something interesting about this database, right? So we have album ID, media ID, and genre ID. We don't see them directly. They are hidden in other tables, so we'll need to learn how to join the tables. However, the Beaver can tell you. You see, it tells you the album, right? Tells you 1, right? For example, 2 is from, right? Tells you the ID, right? This is 1. So 1 is actually MPEG, right? MP3, right? And genre is probably rock, right? So album ID is for those about to rock you. So for example, so 4 is let there be rock, and so on, right? Big ones and so on, right? So you can see the idea, right? Already, but we'll need to join this information later on. So how about order by name, right? Order by name, right? So again, name, right? And again, the capital letter is not important, right? Again, the Beaver helps you again automatically. So if I forget something, right, it will tell you, right? So you say this order by name. You see, it shows you what do you want. Name. Okay, there it is. Again, so it's auto completion like IntelliJ, right? It helps you make these queries. Again, you could press this little play button here, right? Control Enter. I use Control Enter. Control Enter. Okay, and I made a mistake somewhere. Order by name. And let's see, what did I do mistake? Oh yes. You see, I made an error. Why? What's my error? What do you think? The order. This has to go here, right? And this has to go here, right? There you go. Limit comes afterwards. So there is this names, yeah, right? We have here all these track names starting with numbers, right? Look at this all the. So let's do descending. not descending. Control Enter, right? Again, can I make copy? Let's see. I don't know. Control D. No. Control Z. No. I thought there was copy. No, there's no. I guess there's no line copy. You have to Control C, Control V, right? On. Let's see. Limit offset. I could do offset 10, for example, right? So again, order by name, descending. Start with. So instinct. Oh yeah. So there are all these weird letters. So again, you notice how Z, right? Europa, right? I guess I wonder who the artist album is, right? You can sort of figure out. So again, composer also could have been a specific table, but they didn't do this. This table doesn't have all of the, tables. There could be more tables also. Notice also there's some extra stuff. There's price, there's composer, there's how long it is, how many bytes on a file it has. Lots of extra information. Okay, so yes, so that's the basics of how you would work, right? And again, we'll learn later on in our course, we'll learn how to do these queries in a Scala application. But for now, we'll practice, so to say, using the Beaver. Again, it's easier to do it here than do it in an application. So, okay, so what do I want from you? Right, I'll give you some little exercise. So your task, of course, is to go through your SQL Bolt, these exercises, right, up to 5. And install the Beaver and connect your database, right, to your database, like I showed you, and maybe make a simple query for now. And then we'll continue from on there. Thank you.